All right, I'm going to actually make this explanation a little longer than it absolutely has to be, just to kind of, it's got a lot of layers to it if I was to be very thorough, and I would like to be, since this is a good question. All right, so first of all, you need to recognize that there's actually two inequalities going on here that are joined with an intersection or an and I'm going to kind of just do it with my hand here to show you, but if I looked at this side alone, 36 is less than 84 minus 32t. That is one inequality that we could solve. And then the other is, and it's also true that 84 minus 32t is less than is less than 68. So if we look at the intersection of those two regions, that is going to be our solution. So I'm going to actually work this two ways. Feel free to forward if you don't want to see both solutions. But you can treat this as the intersection that it is and kind of treat it like three separate kind of regions. Like if we think of an equation or an inequality, we kind of think of it as having two sides. But in this context, we could think of it as having actually three sides, considering that they have this kind of expression in common. If I do something to this side of the equation, I could do it actually to all three. So as with solving an equation, you're trying to get t by itself. And that's kind of your goal. You want to peel off all of your layers on the t until you have t by itself, doing inverse operations. Now, in this case, we have three sides, but even still, same idea. Solving an equation and an inequality are essentially the same, except for one small thing. If you multiply by excuse me, it's early. If you multiply or divide by a negative number, it basically flips the sign. And I'll just do a little sidebar here. So think about the fact that we are all pretty confident that 2 is less than 3. But if I was to multiply everything by negative, I'd get a -2 and a -3. Well, now if we think of the number line, here's 0, here's -1, -2, -3. That relationship between those two integers has completely flip-flopped to where now -3 is smaller than -2. So if you multiply or divide by a negative, what happens is that relationship kind of gets flipped. Okay, back to what we were talking about. So looking at this, I'm trying to get the t by itself, so I want to peel off all the pieces. We want to keep the t right where it is in the middle expression, but considering the fact that it's got some other things, we're going to have to do that one at a time. So we have this 84 minus 32t. If that's screwing you up, you can think of it as -32t plus 84. Maybe that makes it a little bit more obvious what the next step is. Maybe it doesn't. I don't know. But the next step is going to look like trying to get that 84 to be peeled off, and then we'll try to get the -32 peeled off. Now, opposite operations, currently we're adding by 84, so the opposite operation would be subtraction. Now, when I do that, I'm going to have to subtract it from all three regions. So what is 36 minus 84? Opposite sign, so we're going to subtract and take the sign of the larger. So what is that? 8 makes it 44. So 48, and the larger is 84, so it is going to be a -48. Adding and subtracting does not change our relationship of our inequalities, so it's going to stay as it was. And then here, this is again going to be negative, but what is it? 6 makes it 74, 84. Okay, so just doing that alone, we're at this point. Now, getting the t by itself, we do need to get this -32 to go away. This does imply multiplication, so the inverse operation would be division of that -32. And like I had mentioned before, dividing by a negative or multiplying by a negative will cause our relationship to completely be flipped around. So 48 divided by 32, both of those are divisible by 16. Maybe you knew that, maybe you didn't. You could always use your calculator to confirm that. So this is 3/2. Negative divided by a negative is a positive. Now this less than symbol is going to be a greater than symbol. This reduces, just giving us t by itself. This less than becomes a greater than symbol, and this is actually 1/2. If you're having trouble reducing fractions, you could put this -16 divided by -32 in your calculator. Most calculators have a function where it will allow you to change your decimal into a fraction if it wasn't obvious. I think if you saw 0.5, you'd probably know what it was, but in case it was something like 5/9 that at first glance you wouldn't notice as a decimal, then you could use that feature. I'd be glad to show that to you if you're having trouble finding that. So 32 is greater than t, is greater than 1/2. And even though that is a true statement, usually we don't write it like that. Usually you write kind of small to large, that 1/2 is smaller than t, which is smaller than 3/2. Sorry, it's a 2. My handwriting is just not awesome. I was going to say foul. Okay, so looking at the number line, when you see this, this is the same thing as if you had written 1/2 is less than t and t is less than 3/2. And you could think of this as really being that t is greater than 1/2. Just kind of thinking of the relationship there. So essentially when you're looking, I always like to put 0 on there. We have 1, 2, 3. 3/2 is 1.5 as a decimal, and this is 0.5 as a decimal. It helps kind of look at that. So 1, 2, 3, just for good measure. So if we were to look at t is greater than 1/2, 1/2 is about right here. Now, opened or closed is dictated by whether it's or equal to or not. If you had an equal under here, meaning t could equal 1/2, then we would have a closed circle, meaning that 1/2 is one of the potential solution pieces, but it is not, so it's open. T is greater than 1/2. If we're having trouble like shade left, shade right, I don't know, you can always test a point. So 0 is easy as long as it's not on the edge. So is 0 greater than 1/2? That's a no, and so you would not shade the direction that is a false statement. So it's true that 0 is not greater than 1/2, so I'm going to go the opposite direction. Okay, so this right here, this arrow we've just done, is just for this piece. Now looking here, t is less than 1.5 or 3/2. So here's 1.5. It's still open because this is not or equal to over here. T is less than, again, checking a point. Is 0 less than 3/2? Yes, it is. Okay, so we are going to shade in the direction of the 0 this time. And that would be just doing this inequality and this inequality. Now for this piece. This is an and. It looks at where they are in common. So if you kind of think about where they would both drop down to the x-axis, you have 1/2 not included. So it's not included here, but it is included here, but it's not in both. So it's still going to remain an open circle on both edges of this. And then these pieces are where you are in both intervals. So this would be what your graph would look like. Now some of y'all could have looked at this 1/2 being less than t is less than 3/2 and been like, well, of course it looks like that. And that's fine. Some of us, that's just not incredibly obvious. But that would be your final answer. Now I am going to just show you how we could have solved this using it as 2 from the get-go. And then I will stop this very long video. All right, so I'm going to just rewrite it. 36 is less than 84 minus 32t is less than 68. So we could have written that as 36 is less than 84 minus 32t and 84. I need to drink more coffee before I make videos in the morning. 84 minus 32t is less than 68. So, I mean, these are two ways of writing the same statement. This is called a compound statement. Now, you cannot join everything as a compound statement. It does have to be an and. As y'all come across inequalities that are joined with an or, there is zero way that you can write that as a compound inequality. This implies that you are doing an intersection. So if you're not, like, you cannot combine it in this form. You cannot go from here to here if this and had been changed to an or statement. Just FYI. Okay, so then now we're looking at, you know, if this confuses you less, then go and solve this piece. Go and solve this piece, and you're going to see it still gives us the same t is greater than 1/2 and t is less than 3/2. Okay, so I'll just walk through this once more. So if I again subtract 84 on both sides, I keep saying that, well, it gives us a negative 48. It's negative 32t dividing by negative 32t on both sides. we get this 3/2 is greater than t. Again, dividing by a negative is going to cause that sign to flip. And notice that that gave us just kind of the left side of that compound inequality. And then just to be thorough, doing this once more, subtracting 84 to both sides, we get negative 32t is less than negative 16. Dividing by that negative 32 on both sides, I get t is greater than 1/2, and that and is still hanging out with us. So notice that that does end up giving us the same solution that we had seen here, as well as when we did it as a compound. Obviously, doing it as a compound situation just makes it where you're not subtracting that 84 4 times, because you're doing it here and then again here. Even still, if that just makes your head spin, doing it as a compound inequality, there's no harm whatsoever in doing it as two separate inequalities. The only caveat is that, you have a time factor, right? If this can be done in 30 seconds and this takes you 6 minutes, then we need to at some point figure out how to combine our pieces. But everybody does it a little different. If I can answer more questions, y'all let me know. Hopefully this is a good, helpful video for y'all. Y'all take care.